You can see the flowchart of the lever on your screens. This is very important because by understanding this, you can understand the basic functioning of the lever. In this, we'll be using the input as 5 volt and light from the light source. When light falls on the LDR, the transistor is biased, which triggers the relay, which in turn makes the motor run in forward direction. When there is no light falling on the LDR, transistor will stop biasing due to insufficient voltage. The relay will also stop triggering, which in turn will make the motor come to a halt. Finally, the time has come to start the project. Finally, the time has come to start the project. In a breadboard, we have 4 segments. The top and bottom segments are for power rails, and the middle segment is called component segment, where we'll be making our lever circuit. In power rail segment, the power strips are connected horizontally, and in the middle segment, the strips are connected vertically. One more important thing is, the power rail is again divided into 2 segments, and each segment contains 5 bus strips, and each strip is connected horizontally. This is the 7805 voltage regulator IC. In this, the first pin is input, the second pin is ground, and the third pin is output. We will connect this into the strips of the breadboard component segment. After connecting the IC, we'll have remaining 4 pin under the input pin as input, output pin as output, and similarly for the ground pin as ground. This is the power rail of 9 volt from battery or adapter. The other one is the 5 volt rail from the voltage regulator IC, and these are the power strips for ground. So from power rail of 9 volt, we'll connect a wire to the input of 7805 IC, and the ground pin will be connected to the one of the strips of ground array, and the output pin is connected to the strip of 5 volt array. Now we are having the 5 volt power supply. We'll be making the circuit on the breadboard as per the circuit diagram. One of the 2 legs of the LDR will be connected to VCC. From the second pin of the LDR, we will connect one 10 kilo ohm resistor to the ground. Next, we will connect the NPN transistor C1815. Fix the transistor, keeping the flat surface of it to the front. Then we will connect the current limiting base resistor, whose one leg is connected to the node of LDR and 10 kilo ohm resistor, and other leg is connected to the base of the transistor. The emitter is to be connected directly to the ground through wire. The relay is to be connected now. Here we will connect the relay in the middle of the component segment by separating 4 legs of relay to the upper segment and other 4 legs to the bottom segment. Because the pins of the relay are in horizontal pattern, but the strips of the breadboard are to be connected vertically. The collector of the transistor is to be connected to one of the legs of the coil of relay. The other leg of the coil is connected to the power supply. The second common pin of the relay is connected to power supply 5 volts, and the first common pin is connected to the ground. The normally open pins are to be connected to the load. Here we are using motor as a load. As we can see, this is the DC motor and this is the wheel of the robot. The wheel is to be connected to the shaft of the motor. Here we have to find out the polarity of the motor as per the rotation of the wheel. These are the 2 pins of the motor. These pins are to be connected to the battery After connecting the battery, we have to check whether the rotation is clockwise or anti-clockwise. If the motor is running clockwise, the polarity of the motor is to be marked same as that of the battery. The poles have to be marked on the other motor by using the similar procedure. Now we have found the polarity of both the motors. The motor have to be connected to each other to its alternate poles, as in the positive of one motor is to be connected to the negative of the other and vice versa. The motors are to be connected on both left and right side of the chassis. If you rotate one of the motor by your hand, the other should rotate, and this is how you can check your motor mounting and connections. Connect the battery to the battery cap provided. Connect it randomly and you will notice in one case it will move forward, and if you inverse the polarity it will move reverse. Mount the breadboard on the chassis. In the 9-volt rail of the breadboard, give the connection of the battery, and in the ground rail of the breadboard, connect the negative of the battery.